Now that we have the envelopes covered, let's cover the LFOs, Low Frequency Oscillators. So these are oscillators, just as the ones that we use for producing sound, but we use these oscillators not to produce sound, but to modulate parameters, just like we use envelopes. Now, to demonstrate this, as I've already shown you in the first lesson in modulators, I'm going to show you what this looks like when we actually use an LFO to modulate something. So we have this LFO oscillator that looks like a triangle, and this is exactly the way it's going to affect this value, this parameter, cutoff frequency. So let's see what that sounds like. And you can even follow up how it actually modulates the value of this parameter. You can follow up where it is in its minimum and maximum. Minimum and maximum. Well, right now, this LFO is set to a BPM value. That means that the rate at which it is oscillating is set to be synced to the BPM of the project we are actually in. Meaning that this entire path of the modulation is going to last for 1 bar or 1/4 of a bar. So let's listen to that with the metronome. So all these LFOs are low frequency oscillators that actually modulate our parameters. Of course, I can change the way it's modulating this parameter. So these LFOs in Serum are quite versatile. I can change the shape of it. Listen. Or I can add more points that it's going to depend on for the modulation. And I can even make a beat out of this, like that. So it's quite a powerful tool to actually modulate parameters. Now, what do all of these mean? Well, we already talked about the BPM thing. We can actually make this LFO oscillate in frequency, so actually in hertz. So you see it goes all the way down to 0.001 hertz. So if that's the case, it's going to last a long time to actually oscillate the whole way. Let's see that. See that I can make it move really slow, hence the low frequency oscillators. It takes a long time to oscillate even once, and that kind of a low frequency is not something that you could hear if we had an oscillator that produces sound and makes a sound at 0.01 hertz. From the lesson in the digital audio workstation, you know that people hear frequencies from 20 hertz to 20,000 hertz, so 20 kilohertz. Of course, we can make this oscillator triangle. I'm gonna reset this one. We can make it oscillate really fast, like this. All the way up to 100 hertz, which doesn't seem like much for a normal oscillator that produces sound, but for the modulating one, it really is really fast. We can make it do BPM, so synced to the actual BPM of the song, of the project we are working on. We can make it independent of that, so it will actually play in hertz. We can have a free LFO that does not sync to the actual BPM. And when it's synced to the BPM, it's always a division of musical measurement. And when not, it's always in hertz. Now, anchor means that it's either anchored to the actual timeline, time division in our song. Meaning that if this is 1 bar, it will start oscillating at the beginning of each bar and finish at the ending of each bar, if we do it anchored. If we do it unanchored, it will not actually sync to the time division, to the time code of our project. We could press a note like right here, somewhere in between, and it would start from there. But if we anchor this LFO, it will start always precisely on the bar start. So we can even see that. Let's try that out with the metronome, of course, so we can see how it affects it. So play. So you see, the beginning of the LFO shape is always at the beginning of the bar, and the ending is always at the ending of the bar. And if I play this and I press a note at any point, the LFO is going to start from the point of the actual project timeline. So if I press a note right here, it will start right there. Let's try that out. Let's try that as an example. I'm going to press play and start a note somewhere in between the bars. So you see, it will start to actually satisfy the condition that this LFO is actually synced to the time positions in our project. If I unanchor that and press play, see, it's not anchored to our actual time position in the project. Now, another two are triplets and dotted time divisions. 1/4 a triplet note, so it would actually do a triplet division of this time beat, or a dotted one, which is 1/8, and a dot is like 1/8 and 1/16 note. So that's the time it takes for this entire, so it's 3/16 notes. That's the time it would take for this LFO to actually circulate once. Let's try that. So all of these have to do with the timing. The first three, the trigger, envelope, and off, is the mode for this LFO. The LFO can be free, as you've seen. It will always follow the project. If it's anchored, it will be synced to the BPM if this is on, but we can make it trigger every time we press a note. So it would not matter where we press the note within this time division, it will always start from the beginning of the waveform. It's like restarting an oscillator. You see, it always starts from the beginning. One more thing we can do is go to envelope mode. Envelope mode within an LFO in Serum is making this LFO act like an envelope. So it will play only once, and once it gets to the end, it will just stay there. So let's try something more complex, like this, and let's press it anywhere within the project playing. So it does act like an envelope. It plays only once and holds the rightmost position value that we have. Of course, these two are always the same value since it does have to loop back onto the beginning. That's what LFOs do. They are oscillators. To avoid any clicks or sudden movements in the parameters value, these two are always the same value. So we have these LFOs the same in massive. Let me show you the same thing in massive. Let me initialize the patch. Okay, so now this sawtooth that we hear right here, higher, that's good. Let's apply a filter to that. And now we can use one of these LFOs to actually alter that cutoff point. So I can just click this up, down, left, right arrow and drag it to one of these boxes underneath the cutoff, just like that. Now, once I click on that number, the LFO5 number, and pull up or down, I can change this value using the LFO one way or the other way. So that means bipolar. It will first go up, then down, or first down, then up. changing the actual polarity of this LFO, starting down then up or up then down. So let's hear that. As of now, each one of these LFOs in Massive has two waveforms, just like these, and we have a fader to actually fade between these two shapes of the LFO. Now we're completely sine wave, listen. But if I go all the way down, we're going to be a sawtooth. So going downwards, then skipping upwards. And of course, we can go anywhere in between. Now, for the rate, we can sync that rate and of course have that rate sync to the BPM. We can sync the position of the LFO to the project, just like we did in Serum, and we can restart the LFO every time we press a note. So the same thing. Now, one other thing we can do in Massive, and I'll show you how to do this in Serum, we're going to go back. So is this attack, is this envelope for the LFO? So it's an internal envelope that can help us make this LFO, and I'm affecting the amplitude of the LFO, the strength of the LFO, using this envelope. So I can make this LFO start slowly. You see, so the amplitude of this LFO is starting slowly. That's just one of the built-in things into each one of the LFOs right here, and I can select different kinds of shapes for these LFOs. From where in Serum, I can actually draw them myself. I can also change the phase of these LFOs by just clicking and moving them left and right to see where they're going to actually start from. And that's really useful if you want to create a really crazy, modulation of a parameter that syncs up with the beat. Now, a couple of different types of modulators that we also have in Massive right here are going to be the performer, which is like having different kinds of shapes, just like the ones I drew in Serum, but these ones are preloaded. So I can choose a curve, like let's say this one, or this one, or this one, and then this is going to be the shape that's going to be repeating and altering my value, just like that. So let's hear that. So let's hear that. I need to push up the amplitude. Of course, I can make this pattern shorter and just repeat the first four. And therefore, I have two of these patterns that I can switch from one to the other. So now I'm playing the lower one. Plenty of different iterations that we can do with this kind of a pattern-based, sequence-based modulator, just like this. Now, we can do the same thing in Serum, which I'm going to show you right after this. We just need to get over this last one of the modulators, and it's called the stepper. Now, we can step values right here, just like that. It's just stepped values, so it just switches from one to the other as the steps go by. 1/4 note. So let's try that. It's just stepped out values. Of course, we can make them glide and just turn on the glide, so it will gradually switch from one to the other and see how much we want to glide. So how long is it going to take to switch from this value to that value? So if I turn the glide on to this note is going to be the one that it's going to be switching to, just like that. So the longer the time, the more time it takes to get from this value to that one which we are gliding to. If I turn this level off all the way, the switch from this value to that one is instant. And if I pull it up, Plenty of different iterations that we can do with these, and it gets even more complex once we get into interconnecting these. Now let's go back to Serum and show you how we can recreate all of that in Serum. Now within Serum, as I've shown you the LFOs, we can actually add dots ourselves and make those patterns you've seen right there ourselves, just like that. Or make a stepper like we had in Massive, because this one is actually a free form modulator, so we can actually modulate any way we please. We can add dots, we can create new shapes to our liking, so it's pretty versatile and custom to what we want to do. If we want to glide from a value to a value, we just need to make a glide, and that would be it, just like that. And we can even make that glide, you see, exponential or logarithmic, so whatever we like. This is very versatile in a sense that this LFO can be also a stepper and a performer, all of those at the same time, just like this. So let's add this to the filter, enable the filter really fast. Let's do this less with more resonance so we can hear it. So that's LFOs for you. The first versions of these LFOs were actually just, triangles, squares, like a square wave, just like this, like we had in our stepper. So we had square waves, we had sine waves, we had triangles, and we had sawtooths. Just like in any other oscillator, they were just low frequency oscillators that were used for modulating parameters. Now, digital technology today allows us to have all of these LFOs really modular, really versatile, that we can actually change to our liking and make any kind of shape that we want for the modulator of a certain parameter, like this one is right here. Added in all of the LFOs in Serum are some of the features that you've already seen in Massive right there. So this rise right here is the envelope, if you remember, that we applied to the LFO in Massive. So if I turn that on, let me just find Massive so I can show those to you side by side. So right there in Massive, we had this attack decay envelope that we could actually apply to the amplitude of the actual LFO. We can do that right here by just adding this rise parameter. Rise means that this rise parameter is going to make this LFO's amplitude rise for a certain amount of time. And this time is also syncable, just like this. So we can tell it, okay, have this LFO reach its full amplitude potential in 2 bars. Don't start doing all of this change immediately. Start from 0 and get to the maximum amount of modulation within 2 bars. Let's try that out. See, that takes some time. Now we also have a delay. We can tell it, don't start modulating anything yet. Wait for a bar and then start modulating. You see, it waited for a bar. And we can combine those two. Let's say we say wait for 1 bar and then rise for 1 bar and then get to the maximum. Now that really gives you enough potential to actually have really nice evolving sounds. And also the smoothing is the smooth parameter that we can apply to all of this to have these edges that are really fast in transition smoothed out. So let's try that out. Without the rise and the delay. Now let's see how that's going to affect all of these crazy changes. You see, it takes a long time to actually respond to all of these. Let's try less. You see, so it just smooths out all of the sudden transitions, actually, within the LFO's shape. So that's LFOs for you in a nutshell. Modulators, low frequency oscillators, they can do many different things. And as you see, everything that we can do in one, we can do in the other just as well. It's just a different principle, but once you get the basic idea of what they are and what they do, it's really easy to apply them in any synthesizer.